Hey guys, so today we are starting with chapter D3, which is set theory. Set theory is also in a way is called as Venn diagrams, and this is a very particular topic which can be used in both quants as well as logical reasoning questions to simplify the data. Now the important part about this topic is the language barrier. I mean the language and the interpretation of the statements has to be bang on. So let's see what we have in the concepts. So we have one three parameters set. Let's read the information first. They're saying in a science class of 150 students, 65 students passed in physics, 63 passed in chemistry, 61 passed in biology, 22 passed in both physics and chemistry, 24 passed in both chemistry and biology, and 19 passed in both physics and biology. Also 7 students passed in all the three subjects. Now obviously three Venn diagrams, yani three circles for three subjects that they are talking about, which is physics, biology and chemistry, something of this sort. Now very important, the total is 150. Then immediately after that they are saying 65 passed in physics. Now this is where it becomes interesting. You have to realize that they are not mentioning only physics or something of that sort. They are saying physics, 65 passed in physics, which is a generic representation. And whenever such is the case, what they are exactly meaning is that the entire circle of physics corresponds to 65, something of this sort. Entire circle of physics corresponds to 65. So we'll write it outside the circle. Same goes for the other two. 63 passed in chemistry, entire circle of chemistry is 63, and 61 passed in biology, entire circle of biology is 61, something like that. After that also it becomes very interesting. They are saying 22 students passed in both physics and chemistry. Now again, mind you, they are not saying 22 students passed in physics and chemistry only, or 22 students passed in both physics and chemistry but not biology. If these two interpretations have been there, then we would have marked something in the middle. But because this is again a slightly generic representation where they are talking about physics and chemistry, both physics and chemistry, but mind you, because of the language thing, some bit of biology will also be included in this, which is the intersection of all three. And hence because of that, the 22 that they are talking about are going to be these 22 that they are going to talk about, something like this. Now continuing further, 24 passed in both chemistry and biology, which will be the same part. 19 passed in both physics and biology, which will be this part. And then very important, 7 students passed in all the three subjects, which is the intersection of all three, which is in the middle. And trust me, this is the most important value in this entire diagram. The simple reason is, now that you know intersection of all three, and if you observe, you know that people passing in both physics and chemistry is 22, the entire part, out of which the bottom part is 7. Automatically only physics and chemistry becomes 22 minus 7, which is 15. Trust me, mind this in, remember this very carefully. Sorry, that 22 minus 7 gives you 15, and the interpretation for that region is only physics and chemistry, or it should be physics and chemistry but not biology. So be aware about all these scenarios, because this is where the mistakes happen. Same goes for the other two. You know 19, you know 7, subtraction will give you 12. You know 24, you know 7 on the right side, subtraction will give you 17. Once you again have these in between values, now you know entire circle of physics is 65, out of which you know the three values. Obviously add 3 of them, subtract from 65, you will get only physics, which is 31. Same can be replicated for only chemistry and only biology. Add the remaining 3 values, subtract from 63, you get only chemistry as 24. Add all 3, subtract from 61, you get only biology as 25. Then the last part, which you should not ideally forget, is the total has to always match up with 150. For example, all these values that we have calculated inside the circles, you should add all of them and you should verify whether it is 150 or not, because if it is not 150, then whatever is the difference, that difference are the students who have not passed in any of the 3 subjects. And when you add all the values in the circle, you get the total to be 131. So out of 150 students, 131 students have passed in at least or minimum one subject. That means there are 19 such students out of 150 students who have not passed in any of the 3 subjects, and hence we have written it outside the diagram. And this is how you represent the information, and this is how you tackle the language constraint as well. And the interpretations have to be absolutely bang on. Only then you will be able to do this correctly. Otherwise, you will definitely make a mistake in this. So remember all these things. Now, once the diagrams and the values are clear, let's go for some quick questions based on this. The first question, look at the language again. How many students have passed in at least one subject? At least one is always minimum one, which also in a way means that one or more than one. Obviously, you need to add all the values inside the circle, which we had already done, which had given us the answer as 131. The other way to look at this would have been total में से you should subtract failing in all 3, which is 150 minus 19. So remaining 131 would have passed in minimum one subject for sure. Second question, how many students have passed in at least 2 of the 3 subjects? Which means minimum 2 subjects or more than, 2 or more than 2 subjects, which means only one subjects will get cancelled out, as in only physics, only chemistry, only biology chhod ke whatever are the remaining 4 values inside the circles, these are the ones that you are supposed to add, which are being highlighted right now. Once you add all of these, you get the answer as 51. Question, how many students have passed in exactly one of the 3 subjects? Look at the precision, exactly one, which is only physics, only chemistry, only biology. Just add 3, you get the answer as 80. The next one, how many students have passed in none of the 3 subjects? Obviously we had already calculated that, which is 19 are the ones that have not passed in any of the 3 subjects. Next one, how many students have passed in only physics? Now this is going to become very easy as we move ahead. Only physics, 31. After this, only chemistry, 24. After that, only biology, 25. After that, students have passed in physics and chemistry but not biology. Now look at the language, physics and chemistry but not biology, or in other words, this is only physics and chemistry, which we already know only physics and chemistry is 15, or but not biology. If this would have been physics and chemistry both, we would have marked 22 as the way that it has been given in the data part. Similar way, physics and biology but not chemistry, we already know the answers, which is 12. And I think the last one, chemistry and biology but not physics, the answer is 17. So this is how you simplify the questions. This is how you simplify the information using Venn diagram, or we call it as set theory. The second part is even further more important, which is called as behavior of sets, how sets behave in a certain manner. And for this, we have considered a random piece of numbers apparently, and the 3 circles, the 3 totals are also marked outside the circle. And if you realize in the previous question, I said something that the intersection of all 3 is the most important value. The reason is, if you don't know that value, you wouldn't have got intersection of 2 circles, and then that means you wouldn't have got the lone sets. And now let's see what is the change that happens if we just change that intersection of all 3 wala number. For example, in the original data, it is 10 intersection of all 3, as you all can see. at least one set, at least one यानी addition of all the values inside the circle, which is apparently in this case is 151. Now let's see what happens. The totals are the same, but if we change that intersection of all three from 10 to 15, that means we are increasing it by 5, and you'll surprised to know that intersection of two sets which are just beside the intersection of three, the three values, left corner, right corner, and top of that, reduces by 5. So 9 becomes 4, 18 becomes 13, 12 becomes 7. And what else happens on the lone sets? Only wale values, they increase by 5. Something of this sort. And what happens to at least one? It also increases by 5. So 151 say it will now become 156. So the beauty of this is that if you increase the intersection of all three wala values, suppose 10 se ho gaya 15, which is it is increasing by 5, you don't have to count the remaining values. All you need to know is remember the pattern. So what happens if you increase intersection of all three, intersection of two sets reduces by the same value, and the lone sets increases by the same value, and at least one also increases by the same value. You don't have to add and subtract every time and save the time. Instead, use this property of behavior of sets and just from the reference set just accordingly reduce or increase the numbers with the factor with which you have increased or decreased the intersection of all three. So what you are going to remember, intersection of all three increases, intersection of two sets decreases by the same factor, lone sets increases by the same factor, and at least one also increases by the same factor. For all you know, this all can be reversed. If intersection of all three reduces, intersection of two sets will increase, lone sets will decrease, and at least one will also decrease by the same factor. So in turn, you are going to save a lot of time rather than counting all the values again and again. You just need to take a call based on what you are supposed to do based on the information which is available to you. And this is only going to come in the picture when you don't have intersection of all three ka value given to you ready made, wherein which you will have to start with the assumption as 0 and then proceed further and calculate, and then you will come to know by how much you are going to increase the value of intersection of all three, and based on that the other values will accordingly change. So that's the very important feature of this, which is called as behavior of sets.
This, the first set that we have is exactly same as the one that we have discussed during the concept. So the representation of the data will remain the same, but obviously the different thing here is the questions are different. So data representation part, I'm not going through that again, as it is, as I said, exactly the same as what we have done in the concept. So this was the data that we had. So let's look at the first question. How many students failed in exactly two subjects? So the interpretation is very critical here. Exactly two subjects the students have failed. Yani they have passed in exactly one subject. So passed in exactly one subject, passed in only physics, passed in only chemistry, and passed in only biology. So that turns out to be 31 plus 24 plus 25. That is 80, which is answer option 4 for the first question. Second one, how many students have failed in at least one subjects? Failed in at least one subject, minimum one subject failed, can be two subjects failed, can be three subjects failed. So when you reverse that, is as good as saying not passed in all the three subjects. So you can see the centermost value, the 7 students, they are the ones that have passed in all the three subjects. And except those 7 students, all of the other students have failed in at least one subjects, and that is what the answer should be. So total students were 150 minus passed in all three, that is 7 subjects. That difference gives you 143, and these are the 143 students who have failed in minimum one subject. Third one, how many students have failed in physics but not in chemistry? So reverse that, passed in chemistry but not in physics. So passed in chemistry, again here they have not mentioned only chemistry. So whoever is passing in chemistry will have to include that. but whoever passing in physics, we are not supposed to include that. And when you compare that piece, you get only two datas, which is 24 and 17. That is passed in only chemistry and passed in chemistry and biology only. No physics part we are including. So that gives you 24 plus 17, which is 41 as the answer. Answer option 5 for the third question. So the three questions that we have discussed now had a very different interpretation. And this is what is very critical aspect when you are doing questions based on Venn diagram or set theory, basically. The second set, when you read the data, you would understand there's just one very important piece of information that is not given here, which is intersection of all the three. And that is your idea that you should be thinking about behavior of sets. So that was the idea that we had discussed in the concept at the end part of the concept, that whenever intersection of all three is not mentioned, you start with assumption of that value to be zero and then proceed further. So first of all, let's represent the data. 90 students have got calls from IM, 80 from XLRI, 65 from SPJ, 55 from IM and XLRI, 45 from IM and SPJ, and 40 from XLRI and SPJ. So even if you look at the questions, you'll also understand whenever intersection of all three is not given, and that means behavior of sets is going to be in picture. The questions that they will ask cannot be the exact values. They will always ask the range bound questions, that is the minimum and the maximum values basically, and those are the only four questions. So let's assume that the intersection of all three is zero, and then you will get the remaining values by doing the appropriate calculation, and that is the base value. So let's calculate at least one call, addition of all the values, which turns out to be 95. And now let's read the first question. So first question is, and before that, just a quick recap of what behavior of sets is. So if we increase intersection of all three by a certain value, then intersection of two sets, the three values around that, will decrease by the same number. And the single lone sets, they will increase by the same number, and at least one will also increase by the same number. This idea will help you to not every time add and subtract all the each and every values, because you don't need that, and that will be a lot of time consumption unnecessarily. So to avoid that, this is what the property of behavior of sets that you can apply here. So when we do that, fourth question, minimum number of students who have all the three calls, and an intersection of all three has to be minimum. And the fifth one immediately after that, related to that, minimum number of students who have at least one call. So this was the base value. And now clearly you understand when you assume intersection of all three as zero, you are having some of the numbers as negative, which is absolutely not possible when you think from the common sense perspective. Mathematical base, it is okay, but common sense perspective, it is not okay, because these are the number of students who are getting some calls from some institute. They cannot be negative for sure. So the least that they can be is zero, or non-negative for that matter. So the least that they can be is non-negative, that is zero, and the maximum is minus 20. So let's try to make that zero. That means we'll have to add all the values by 20. So that means intersection of all three, the minimum that it can be, it cannot be zero for sure. The minimum that it can be 20, considering these three numbers. So let's apply behavior of sets here. Intersection of all three increases by 20. Intersection of two sets around them decreases by 20, and the lone sets, they are increasing by 20. So first answer is done. Minimum number of students who have at least, or who have all three calls, that is 20 is the answer. And then immediately after that, second question was minimum number of students who have at least one call. If you also remember the property of behavior of sets, if you increase the intersection of all three, then the at least one value will also increase by the same number. So we don't need to calculate, but in case you want to just confirm, very quickly add all the values now inside the circle to get the actual answer of minimum number of students who have at least one call. But you don't need that, because on the base value, that value was 95. You apply the property here as well, and you just add that value by 20, which will give you the answer as 115. And even if you add all the values right now from the circle inside, you'll also get the same answer, which is 115. So that's your two cases, minimum cases. First one 20 and the second one 115. This is how you can calculate. The second two questions obviously are based on the maximum value. Maximum value, let's continue from this part. Maximum number of students who have all three calls and maximum number of students who have at least one call. Now always remember, you can again start from the base scenario assuming intersection of all three as 0 and take a call, or else you can continue from this value as well if you are able to identify. So always remember, maximum number of students who have all the three calls, that is intersection of all three, can be maximum considering the intersection of two sets. So when you consider intersection of two sets, these are the three values that we can highlight: 55, 45, 40. So always remember, out of these three values that have been highlighted, you're always going to consider the minimum value. So minimum value is 40 because you cannot increase intersection of all three beyond 40, because the other two, 45 and 55, will still be positive. But this one, 40 on the right side, will turn out to be negative, which is absolutely non-negotiable. So the maximum value that intersection of all three can be is 40. And that means right now it is 20. So that means again we'll have to increase it by 20. And again, when we apply behavior of sets, if you increase the intersection of all three by 20, intersection of two sets will decrease by 20, lone sets will increase by 20, and at least one will also increase by 20. So those will be your two new answers. Question number 6, maximum students who have all the three calls, answer is 40. And seventh question, maximum number of students who have at least one call, 115 plus 20, which is 135. So those are the next two answers. And this is how we can practically apply the concept of behavior of sets. Always remember, the clue to identify this is when intersection of all three will not be given. You assume that with 0, work around with the base condition, and then do the changes as far as the requirement is concerned with. The next set is a very interesting one because here there are more than 3 values that are in picture. And the reason that we have kept this is to make you introduced to a new way of simplifying the data, which is plotting the data. So again, two same questions that we will have: minimum number of housewives who watch all the 4 channels and maximum number of housewives who watch all the 4 channels. The first question is minimizing the overlap between all the sets. So there are 200 housewives. First data, 190 are watching Sony. So let them be these 1 to 190. If we number them, they are watching Sony. Then because we are supposed to minimize the gap, so while representing the next information, don't start from 0. So whatever is the non-utilized value, start from that value. So for example, the next data is 145 housewives, they are watching channel Z. So what we will do, 191 to 200, the ones that are not watching Sony, let them watch Z first. So those 10 are included there. That means remaining 135. Now there is no option, but we'll have to take them from 1 to 135. So this is how the innovation of representing the data should be done. Next data, 140 are watching Star. Now out of 200, 135 are watching both the channels. So that means 65 are not watching both the channels. So let them watch Star first. And then the remaining 75 from 1 to 75 will watch Star. And the last information, 130 are watching Imagine. Out of 200, 175 are watching all the 3 channels together. That means 125 are not watching all the 3 channels together. So let them first watch Imagine, and then the remaining 5 will watch Imagine from the bottom part. And now if I ask you how many housewives are watching all the 4 channels together, obviously the answer is 5. But always remember to do this last check, which is very critical and it can be easily forgotten, but sometimes this is also responsible to change your answers, and you'll realize that when we do some questions in the next set. But right now the importance is always check at the last part whether have you accounted all the numbers. So here, did we account all the 200 housewives? Then yes, definitely. This is where we have accounted all the 200 housewives. 1 to 190 are some exclusive 190 housewives, and then the 10, 191 to 200, the ones that were watching Z earlier, those are the additional 10. So that means yes, we have accounted for all the 200 housewives, and that means we don't need to make any changes in the answer. So eighth question, answer is 5. Similarly is the ninth question, wherein which we are maximizing the overlap. And one different way of representing that data is you start all the representations from 0. So 1 to 190 Sony, 1 to 145 Z, 1 to 140 Star, and 1 to 130 Imagine. And now if I ask you how many housewives are watching all the 4 channels together, the answer is drastically changing. It is turning out to be 130. But when we do that last check, that was very, very critical, that have we accounted for all the 200 housewives? Then no, we have not accounted. We have only accounted for 190 housewives. That means these 10 housewives are unaccounted. And now this is where the importance comes into the picture. So one of the sets will always act as a reference set. So we are not supposed to remove from that. Also, don't remove from 130, otherwise your answer will go down. That will not be a maximum number. So one set reference, don't directly remove from the answer. If you have anything extra, remove from that. So clearly I can see Z has 15 extra or Star has 10 extra. Now it is immaterial from where I remove this, because it is not going to change my answer, because I require only 10 housewives that I can remove extra from either Z or I can remove it from Star without affecting my answer. So this is just a formality that they are removing it from Star. Even they remove it from Z, it will not going to change the answer. So when you do that, now we have accounted for all the 200 housewives, but fortunately the answer is still the same, which is 130. So ninth question, answer is 130, option 3. So this is a different approach for plotting approach. When you have more than 3 sets, you don't need Venn diagrams for that. But if you understand the pattern, minimum overlap between all the sets and maximum overlap between all the sets. For that, we use the pattern finding or plotting approach basically. Similar is the 10th and the 11th set. Talks about some institute has some faculty members teaching few subjects. Same 2 question, minimum number of faculty members who teach all the 5 subjects. So the overlap has to be minimum. Let's start plotting. 100 faculties are there. First information, 60 are teaching reasoning. And if you remember from the previous set, because we are minimizing the overlap, the ones that are not teaching reasoning right now, let them teach the other subject. So 55 are teaching DI. So out of 100, the remaining 40 that were not teaching reasoning, let them teach DI. This is how you can minimize the gap while filling the remaining places first and then utilizing the original slots basically. So remaining 15 will come here. That means 15 faculties are now teaching both the subjects together. Then the third subject, grammar, is taught by 50 faculties. 15 are teaching both the subjects together. That means 85 are not teaching both the subjects together. So let them first teach grammar. And what you observe now after plotting grammar in this remaining empty space of 85, you're still left out with many more empty spaces as a common part. And now if I ask you, looking at this representation, how many faculties will teach all the 3 subjects together, your answer will be 0. And this, if you're smart enough, this is what will enable you to understand that you should not even bother going further, because if 3 sets mein there is nothing common, then 4 ya 5 set mein how there can be anything common? And that should tell you the answer is 0 for this question. But still, just a formality. You plot the next data from anywhere, it doesn't matter. You plot it from upper side, you plot it from bottom side, it doesn't matter. So 1 to 45 RC, remaining 40 quant, it doesn't matter. If I ask you how many faculties are teaching all the subjects together, 0 is the answer. The very, very important last check, did we account for all the faculties? Yes, we did account for all the faculties. So 10th question, answer is 0. After grammar representation only, you should have understood that. These are small things which will save your tremendous amount of time while doing all these questions as well. The 11th one, very important. Same data, but maximizing the overlap. And if you remember, maximizing the overlap, all the representations has to be done from the bottom part. So let's do that. And now if we ask you how many faculties are teaching all the 5 subjects together, your answer will be 40. But if we perform the very important last check, did we account all the 100 faculties? Then definitely no. We have only accounted 60 members. That means the remaining 40 members are unaccounted. So as usual, now we need to make sure how this 40 comes from. So one set will act as a reference. So 60 will act as a reference. 40, don't remove directly from that. Your answer will go down. So first try to remove from the extras. So when you observe, DI has 15 extra, grammar has 10 extra,